Hello, today's topic ultrasound. What is ultrasound? So, ultrasound is the periodic mechanical disturbance of an elastic medium such as air. Sound is mechanical wave produced by vibrating bodies. Longitudinal wave propagates by medium by compression and refraction. Ultrasound is frequency. Frequency of the sound wave is the same as the rate of oscillation of the sources. For human being is audible sound range. What is that? 20 Hz to 20 kHz. That means 20 to 20,000. Okay. Frequency involved in speech and music is about 30 Hz to 40,000 Hz. Higher in children about 20 kHz. Lower in old is about 16 Hz to 20 Hz. Now, difference. Sound waves, electromagnetic waves. So first, what is the sound waves? What is the difference? Sound waves. So, require elastic medium for transmission. Longitudinal waves and propagates by compression and refraction. Second, electromagnetic waves can travel even in vacuum. Both longitudinal and transverse wave particles go up and down. Infrasound vibration below 20 Hz frequency is called infrasound or infrasonic radiation. During earthquake, infrasound is produced, but it is out of audible range of human. Ultrasound, what is that? So, ultrasound energy or ultrasound describe any vibration at a frequency above the sound range, that is 20 kHz. Frequency of few megahertz that are typically used therapeutically range from 0.5 to 5 megahertz. Nature of sonic waves. So sonic waves are the series mechanical compression and refraction in the direction of travel waves. Hence this is called longitudinal waves. So this is turning works and sound waves. So compression, refraction. Okay. So velocity depends on elasticity. That means ability to deform of medium. Second, sonic wave pass more rapidly through material in which the molecules are close together. So velocity is higher in solids and liquid than in gases. Sonic waves velocity first in air 340 milliseconds, in bone 2800 ms, in steel 5850 milliseconds. So for waves equation, the where f and are inversely related and v remains constant. So compression, refraction, this is volts. Compression, refraction, compression, refraction. Compression, refraction. Waves absorption. Propagation of sound wave depends upon the transmission of energy from particles to particle. That means sometimes the energy is absorbed rapidly and some pass without loss. As molecules jostle and collides with another, energy will be transferred from one to another. Transmission, it depends on elasticity. Elasticity is the ability of material to undergo deformation called acoustic impedance of medium, density of medium, velocity of medium. Metal very high, water have lesser, air have very low. During transmission of sound wave from one medium to another medium, either sound wave can be reflected, refracted and absorbed. So low velocity medium, that is high velocity medium. The production of therapeutic ultrasound. What is that? So the production of high frequency ultrasound waves used in therapeutically mechanical oscillation frequency in range from about 1 to 3 MHz are needed. Ultrasound can be produced using piezoelectric crystal. What is piezoelectric crystal? So, piezoelectric crystals are crystalline solids which have as a special property they changes in thickness in response to an applied voltage. Many types of crystal can be used to produce therapeutic sound, but the most favored are quartz. Some synthetic ceramic materials such as barium titanate and lead zirconate titanate. If alternating voltage is applied to a piezoelectric crystal, that its thickness will change and oscillatory manners. Okay, thickness of crystal should be suitably cued so that is resonate at a chosen frequency. So again, this is volt, compression and refraction. So compression, refraction. All therapeutically ultrasound generate have a handheld probe with a treatment head with a piezoelectric crystal is mounted. Piezoelectric effect. There are two forms of the piezoelectric effect. First is direct, second is reverse, that means indirect. So, the direct piezoelectric effect, if the generation of an electric voltage across a crystal when the crystal is compressed, that says example, mechanical compression voltage 0 volts, that is compression. The reverse piezoelectric effect, if the contraction or expansion of crystal in response to a voltage applied across its face, a change in the polarity of the applied voltage cause a contracted crystal to expand and vice versa. Components of ultrasound circuit. What is the main components of the ultrasound circuit? Main supply. This is the alternating current normally of 220 volts having frequency of 50 Hz. Transformer. A step of transformer is used to increase the voltage of the current. Rectifier, where current is converted from alternating current to direct current. Oscillator. This is to give high frequency oscillating current to the output circuit. Amplifier. This is to increase the magnitude of current. Coaxial cable. It is a simple wire covered by a metallic plate and separated by insulating material. It takes the current to the transducer. Transmission of sonic waves. The metal plate of a treatment head moves backward and forward to generate a stream of compression wave that form the sonic beam due to the fact that the wavelength of these waves is much similar than the transducer phase. The sonic beam is roughly cylindrical and of the same diameter as the transducer head. The beam non-uniformity ratio is the ratio between peak intensity and average intensity in the beam. The lower the BNR, the more uniform the beam. What is BNR? Beam non-uniformity ratio. The short form is BNR. So you don't confuse. Wave emitted from the different places on the face of transducer will travel in a space in front of transducer. So as see as a diagram, near field peak, average and SS intensity, transfer distance across the beam. So some waves cancel, but other reinforce so that the net result is a very irregular pattern of sonic waves in the region close to the transducer phase called the near field Fresnel zone. The region beyond this, the far field of Fraunhofer zone. This is ultrasonic sources, Fraunhofer zone and Fraunhofer zone. And this is distance. So this is a vibration. So diagram near field is its intensity, far field distance from the transducer and axial transfer beam profiles. Clear? The length near field will depend directly on the square of the face inversely of the wavelength. Show length of Fresnel zone is equal to R2 by therapeutically ultrasound utilizes the near field and hence is irregular. This is relatively more energy carried in the central part of the cross section of the beam. Boundaries between media. What is that? What is the boundaries between media? So sonic waves involves vibratory motion of molecules so that there is a characteristic velocity of wave progression for each particular medium. Energy transmission waves. Energy transmission depends on the actiosonic impedance of the medium. Energy carried by wave also depend on its frequency and amplitude. Various changes come to a boundary. Velocity changes according to a AI of medium. Frequency remains same, wavelength must change. Some energy is reflected back. This amount of energy reflected is proportional to the difference in AI between two media. Example, water and glass have a higher difference, so reflected energy will be 63%, whereas in case of water and soft tissue, reflected energy will be 0.2% only. If wave strike as a boundary at some other angle, the reflected wave will travel away from the boundary at the same angle. If some energy is reflected back, frequency remain the same but amplitude will decrease. Refraction change in direction of the sonic wave will occur due to the difference in air intensity. The original and reflected are traveling in opposite direction. So at some point they will be combined, producing a much greater amplitude, and at other point they will cancel out. This trends to produce a stationary or a standing wave. Half wave depth, that means half value depth. What is that? There is no depth at which all the energy has been absorbed. The depth or distance and which half is initial energy have been absorbed is called half value depth. It depends on frequency, nature of medium. Protein contents and absorption of ultrasound various tissue. So blood, fat, nerve, muscle, skin, tendon, cartilage, bone. Latest protein content, this is greatest protein contents. Latest absorption ultrasound, that is US, greatest absorption ultrasound of US. Heating of the tissue due to the ultrasound. What is the heating of the tissue due to ultrasound? So, rate of tissue heating is influenced by a blood flow which constantly carries heat away. In highly vascular tissue, heat would be rapidly dissipated, preventing any temperature rise, whereas less vascular structure experience a relatively greater temperature rise. Attenuations of the ultrasound in tissue. The loss of energy from the ultrasound beam in the tissue is called attention. It depends on absorption and scattering. Absorption accounts for 60 to 80% of energy lost from the beam. This is the scattered energy may also be absorbed other than the region to the which ultrasound beam is applied. A scattering is caused by a reflection and refraction where there is high difference in air. Shear wave can also be formed which transmit energy along the periosteal surface at the right angle to beam. Testing of apparatus, that means how to test. So prior to any treatment, if sensible, to check their output from the machine. This can be done by placing the treatment head just below surface of suitable containers and absorbing the disturbance which appearance in the water. Thank you so much.